The Big Bang Theory, it's a name that sparks curiosity and wonder. It's the leading explanation for how our universe began. This theory attempts to answer the biggest question of all: where did everything come from? In this cosmic adventure, we'll journey back to the very beginning. We'll explore the birth of the universe, the formation of the first stars, and the ongoing expansion that continues to this day. Fasten your seatbelts. It's going to be a wild ride. Imagine everything in the universe squeezed into a tiny point, smaller than an atom. This point, called a singularity, was unimaginably hot and dense. Then, about 13.8 billion years ago, something incredible happened. The singularity began to expand. It wasn't an explosion in the traditional sense, but rather an expansion of space itself. Imagine a balloon being inflated. The universe stretched and cooled as it grew, much like the surface of that expanding balloon. In the first fraction of a second, the universe was a chaotic soup of energy. As it cooled, this energy began to condense into particles. These weren't atoms yet, but even smaller building blocks like quarks and leptons. The universe continued to cool, and these fundamental particles started to combine. Protons and neutrons formed, the building blocks of atomic nuclei. The universe was less than a minute old, and the stage was set for the formation of the first elements. For hundreds of thousands of years after the Big Bang, the universe was opaque. Light couldn't travel freely because it was constantly scattered by free electrons. The universe was like a dense fog. Then something amazing happened. The universe cooled enough for electrons to combine with protons, forming the first atoms of hydrogen. This event, called recombination, made the universe transparent. Light could finally travel freely. This first light, now stretched and cooled, is still detectable today as the cosmic microwave background radiation. Section 5. From Darkness to Galaxies. This is the story of how the universe transitioned from a state of darkness to one filled with the light of countless galaxies. After recombination, the universe entered a period known as the Dark Ages. This era was characterized by the absence of any luminous sources, making it a time of profound darkness. During this time, there were no stars yet, only vast clouds of hydrogen and helium gas. These primordial elements were the building blocks of everything that was to come. But gravity was at work, slowly pulling these clouds together. The invisible force of gravity began to shape the future of the universe, drawing these gas clouds into denser regions. Over millions of years, gravity caused these gas clouds to collapse. This process was slow and gradual but relentless, as gravity continued to pull the gas clouds inward. As they collapsed, they heated up, eventually becoming hot and dense enough to ignite nuclear fusion in their cores. This was a critical moment in the history of the universe. The first stars were born, blazing with light and heat, illuminating the early universe. These stars were massive and short-lived, but they played a crucial role in shaping the cosmos. These stars, in turn, began to clump together, forming the first galaxies. The gravitational pull of these stars drew them into larger structures, creating the galaxies that we see today. As time went on, galaxies began to interact with each other, colliding and merging to form even larger galaxies. These cosmic collisions were violent and spectacular, reshaping the structure of the universe. Supernova explosions from dying stars enriched the surrounding gas with heavier elements, which in turn fueled the formation of new stars. This cycle of star birth and death continued, driving the evolution of galaxies. Over billions of years, galaxies evolved into various shapes and sizes, from majestic spiral galaxies to massive elliptical galaxies. Each galaxy is a testament to the dynamic and ever-changing nature of the universe. Galaxies themselves are not isolated. They are part of larger structures known as galaxy clusters. These clusters are interconnected by vast cosmic webs of dark matter and gas, forming the large-scale structure of the universe. Today we can observe these distant galaxies and the cosmic web that connects them, giving us a glimpse into the history and evolution of the universe. From the darkness of the early universe to the light of countless galaxies, the story of the cosmos is one of transformation and wonder. Modern telescopes and scientific instruments allow us to peer back in time, studying the light from these ancient stars and galaxies. Through these observations, we continue to unravel the mysteries of the universe and our place within it. As we look up at the night sky filled with stars and galaxies, we are reminded of the incredible journey from darkness to galaxies. It is a journey that continues to inspire and captivate us as we seek to understand the cosmos and our place in it. Section 6. A universe on the move. The universe didn't stop expanding after the Big Bang. In fact, it's still expanding today. We know this because we observe distant galaxies moving away from us. This expansion isn't like galaxies moving through space. Instead, it's space itself that's stretching, carrying the galaxies along with it. Think of dots on the surface of that expanding balloon again. As the balloon inflates, the dots move farther apart, not because they're moving across the surface, but because the surface itself is expanding. Section 7. Echoes of the Big Bang, the evidence. The Big Bang Theory isn't just a cool story, it's supported by a wealth of scientific evidence. One key piece is the cosmic microwave background radiation, that faint afterglow of the Big Bang we discussed earlier. Another piece of evidence is the abundance of light elements in the universe, like hydrogen and helium. The Big Bang Theory accurately predicts the ratios of these elements. And then there's the redshift of distant galaxies, which tells us the universe is expanding. Section 8. The Big Bang, a universe unveiled. The Big Bang Theory is the best explanation we have for the origin and evolution of the universe. It suggests that the universe began as an incredibly hot and dense point roughly 13.8 billion years ago. This singularity, as it is known, contained all the matter and energy that would eventually form everything we see around us today. It's a story that began with a tiny point of unimaginable density and unfolded over billions of years into the vast cosmos we see today. In the first fractions of a second, the universe expanded exponentially in a period known as cosmic inflation. This rapid expansion set the stage for the formation of subatomic particles and simple elements. From the first moments after the Big Bang to the formation of stars and galaxies, the universe has been on an incredible journey of expansion and evolution. As the universe cooled, particles combined to form hydrogen and helium, the building blocks of stars. Gravity pulled these elements together to form the first stars and galaxies, lighting up the cosmos for the first time. The universe has been on an incredible journey of expansion and evolution. Over billions of years, these stars and galaxies have continued to evolve, forming complex structures like clusters and superclusters. The process of star formation and death has created heavier elements, which are the building blocks of planets and life as we know it. And this journey is still ongoing, with new discoveries constantly refining our understanding of the cosmos. Modern observatories and telescopes allow us to peer deeper into space and further back in time, revealing the universe's secrets. Astrophysicists study this data to understand phenomena like dark matter, dark energy, and the ultimate fate of the universe. Each discovery brings us closer to understanding the grand tapestry of the cosmos, a universe unveiled in all its glory. Section 9. Our place in the cosmic dance. As we contemplate the vastness of the universe and the incredible events of the Big Bang, it's humbling to consider our place in it all. The universe is a vast expanse, filled with countless galaxies, stars, and planets, each with its own story and history. The sheer scale of it all is almost beyond comprehension, stretching our minds to their limits. We are stardust, forged in the hearts of long-dead stars. Every atom in our bodies was created in the fiery cores of ancient stars that lived and died long before our solar system was born. These stars exploded in supernovae, scattering their enriched guts across the cosmos, seeding new stars, planets, and eventually, life itself. This cosmic connection binds us to the universe in a profound way. The quest to understand the universe is a testament to human curiosity and our desire to unravel the mysteries of the cosmos. From the earliest astronomers who charted the stars with the naked eye, to modern scientists using advanced telescopes and space probes, our journey of discovery has been relentless. Each new discovery brings us closer to understanding the fundamental nature of reality. The Big Bang Theory is a triumph of scientific inquiry, a model that explains the origin of the universe from a singular point of infinite density and temperature. This theory has been supported by a wealth of observational evidence, from the cosmic microwave background radiation to the distribution of galaxies in the universe. It provides a framework for understanding how the universe has evolved over billions of years, and it reminds us that even the most profound questions about our existence can be explored through observation, experimentation, and the power of human ingenuity. The scientific method has allowed us to peel back the layers of the cosmos, revealing its secrets one by one. It is a testament to our species' relentless pursuit of knowledge and our unyielding desire to understand our place in the grand scheme of things. As we look up at the night sky, we are reminded of our smallness in the face of such grandeur. Yet, it is this very smallness that makes our existence so precious. We are a part of the universe, and the universe is a part of us. Our atoms, our thoughts, our dreams, they are all woven into the fabric of the cosmos. This realization can be both humbling and empowering, as it connects us to something far greater than ourselves. The wonder of the cosmos is something that can be shared by all, regardless of age or background, whether through a telescope in our backyard or through the lens of a space probe millions of miles away. The universe invites us to explore, to question, and to dream. It is a journey that never ends, a dance that continues through the ages, with each generation adding its own steps to the cosmic ballet. Our place in the cosmic dance is not just as observers, but as participants. We are explorers, adventurers, and dreamers, driven by an insatiable curiosity to understand the universe and our place within it. As we continue to push the boundaries of our knowledge, we are reminded that the journey of discovery is as important as the destination. It is a journey that defines us, shapes us, and connects us to the cosmos in ways we are only beginning to understand. So, as we gaze up at the stars, let us remember that we are a part of this magnificent universe. Our place in the cosmic dance is a testament to the power of human curiosity, ingenuity, and the unending quest for knowledge. It is a dance that we are all a part of, a dance that will continue for as long as there are those who look up at the night sky and wonder,